Hello, welcome back. We're going to be doing some more problems here. All right. Solving linear equations, general equations. And that's chapter 1.3 of this book here. It's free, it's online, anybody can use it. It's an open source textbook, beginning and intermediate algebra. And I often tell you that a lot of math teachers are no good. That's why you need tutors. That's why you're online learning this math with me. But this math teacher, Mr. Tyler Wallace, made this free book. Imagine, he made it available for everyone and you can go get the solutions, except I'm working the problems with you because I want you to learn this stuff. And I always feel it's just better when you have someone explaining things to you. So I click on this and I will get to here. Section 1.3, solving linear equations. And once again, I'm just going to go over like the examples they give, and then I'll do all the problems. So it says objective, solve linear equations with variables on both sides. So what they're saying here is often as we are solving linear equations, we need to do some work to set them up in a form we are familiar with. This section will focus on manipulation of an equation. We are asked to solve in a way that can use our pattern for solving two-step equations to ultimately arrive at the solution. Math involves detecting patterns, pattern recognition, and by practicing, those patterns get burnt into your brain. So the same way as it used to be hard to do 4 plus 5 equals 9, by doing more math, it builds on the old math and you get that stuff. It just like it clicks at one point. It clicks differently for some different people. For some people it clicks very late in their life, very late, like it takes them like, let's say 6 hours of work. Other people will click after 1 hour work, but pretty much up to functions and trig, it will eventually click for almost everyone. It's just for some people it's going to be a heck of a lot more work, and that's fine. For most people, it will be a heck of a lot of work. Usually, algebra is where a lot of people stop dropping like flies, either by lack of effort, lack of good teaching, or often both. And more often than I think the mathematical people would like to admit, by lack of avenues for learning. So, let's take a look at this. One issue that needs to be addressed is parentheses. Often parentheses can get in the way of solving an otherwise easy problem. As you might expect, we can get rid of an unwanted parenthesis by using what's called the distributive property. That's a very big word, distributive property. I will talk about it later. This is shown in the following example. Notice the first step is distributing, then it is solved like any other two-step equation. So they make it sound so easy, right? Of course, it never is. This is actually pretty hard. We're going to think about it in a different way now. What we're going to do is we're going to look at this problem. So let's take example 59. 4 times 2x minus 6 equals 16. Now, we always told you, if you remember from the previous lessons, first you do, what is it? Parentheses, exponents, right? Parentheses, exponents, multiplication and division, addition and subtraction, right? So we see the parentheses here. We want to do this right now, right? We should be taking this minus this and coming up with a number, except we can't because one of these entities has an unknown and the other one here, it's all known. So there's a trick. We use what's called the distributive property, and the only thing that means is I'm just gonna focus on this part of the equation and I'm gonna put known numbers. So let's say it was 4 and this would be 2 times, let's say x was 3 minus 6, right? So the first thing we would do is the parentheses, right? And in the parentheses we would do the multiplication and division first and then the addition and subtraction after. So we'd have 6 minus 6, right? 2 times 3 equals 6. Times 4, and that equals 0, so it'll be 4 times 0 equals 0. That example sucks. Let me think of a better one. 59, well, it's the good answer, but I'm trying to make a broader point here. 2x minus 6 equals 16. All right, so let's take 4 times, let's say 2 times 4. Like instead of it being an unknown, we would have everything known here. Good. So the first thing we would do is 2 times 4, and that's 8. You saw how I did that, right? 2 times 4, and I brought this here. The minus 6 is here, and the 4 is here. 4 minus 6 equals 2. 8 minus 6 equals 2. 4 times 2 equals 8. You see how I did that? I did not use the distributive property. Now let's look at what would have happened if I would have used the distributive property. Let's do this problem using the distributive property. Here, 4, 2 times 4, minus 6, 4, 8 minus 6. Okay, we stop right there. So far, everything's the same. What the distributive property says is if you take this and you multiply by this, and then you take this and you multiply by this, it should give you the same answer. You can do that because you're multiplying your parentheses by something. Sounds bad? So anytime you see a minus or a plus sign here, you can do what's known as the distributive property. So let's take a look at this. 4 times 8 equals 32. 4 times minus 6 equals minus 24. That equals 8. You see it works. So, and I could put any number here. It'll always work. This side will always be equal to this side. So now let's do the problem. That's called the distributive property. So 4 times 2x minus 6 equals 16. All right. What is this saying? 4 times 2 times x, right? 4 times 2 times x, right? Because 2x is really 2 times x. 4 times 2 times x minus 4 times 6. 4 times 6 equals 16. You see how we did that? I did the exact same thing as the other problem. So what I did was I multiplied this by this over here, and then I multiplied this by this over here. Always looking to the left-hand side of the number for the sign. Here there's nothing, it's positive. Here there's a minus, it's negative. Always look to the left of the number for whether it's a negative or a positive. Now, let's do the math here. 4 times 2 times x. 4 times 2 equals 8, times x equals x. For 8x, right? Minus 4 times 6 equals 24. Equals 16. We brought that down. We did that multiplication. We did this multiplication. So now it looks kind of familiar. It looks like the problems we were doing just before. We have an unknown and a known. And here we have another known. And what was I telling you in the previous class? Put a great big line right here at the equal sign. We want to get our unknowns on one side and our knowns on the other. So what we do is 8x goes right here. Minus 24, I have to add 24 to this side, and I have to add 24 to this side. So minus 24 plus 24 equals 0. 16 plus 24 equals 40. So as I was saying the previous time, when you have x, to get the x, you have to get rid of this 8 here. So what is this saying? 8 times x. Anytime I take something and I multiply it by anything, if I divide it by the same number, I will be left with whatever is left, right? So if I have 8 times x divided by 8, this crosses out and I'm left with x, right? So 8 times x divided by 8. And if you divide one side by 8, you have to divide the other side by 8. 8x over 8. That's like this. This equals 5. X equals 5. Is that the right answer? Yes, it is. So that's how you do that one. Really complicated stuff because we're doing a whole bunch of steps, but practice, 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 practice as usual. Let's keep reading what they say. Often after we distribute, there will be some like terms on one side of the equation. Example 2 shows distributing to clear the parentheses and then combining like terms next. Notice we combine like terms. We only combine like terms on the same side of the equation. Once we have done this, our next example solves just like any other two-step equation. So we're adding a step. Let's do this one a bit more quickly. 60. So that's 3 times 2x minus 4 plus 9 equals 15. Once again, we learned a long time ago that we're always supposed to solve the parentheses first. This becomes very confusing when you put unknowns. The unknown here is this 2x. So we will multiply using the distributive property. We're distributing this 3 over this thing and this thing because we have something minus something. It could be plus something also, that's fine. So 3 times 2 times 8, right? So this thing here is 2 times x. So what we're saying is 3 times 2 times x. And that equals 6 times x, which equals 6x. We have to agree on that. The next one is 3 times minus 4. You always look to the left of the number to see the sign. 3 times minus 4 equals minus 12. So 6x minus 12. We drop this down right here. Plus 9 equals 15. We're trying to get rid of those parentheses, right? Because we can't do anything with it because inside the parentheses there's a number with an X or a Y or some letter that we don't know what it is. We don't know what the number is. So taking a look at this, now they say to combine like terms, right? So this is unknown, right? This is one thing. This we know, this we know, and this we know. We know what negative 12 is. We know what 9 is. So what we're going to do is we're going to toss all this stuff over to this side. Remember my dotted line here? Toss all this stuff over to one side. So minus 12 plus 9 equals minus 3. So that's 6x minus 3 equals 15. We want to get rid of this minus 3 and put it on the other side, right? Because we want the things we don't know on one side and the things we know on the other. So minus 3 plus 3 here plus 3. That is 6x equals 18. So if we go right up here, 6x equals 18. Remember I was saying I want x. So what are we doing to x here? We're saying 6 times x. We are multiplying x by 6. And to get rid of that 6, we have to divide by 6, right? If you multiply something by a number, you have to divide by a number to come back to the original number. So it's what I'm trying to say to you is that x times 6 divided by 6 equals x. And since I did it to one side, I have to divide by 6 to the other. And x equals 3. So that is how we solve that equation. So up till here, this is brand new material. Everything down is the stuff we did in the previous lesson. But it doesn't matter if we did it already. We're going to go over it thoughtfully. Next video, we continue.